Hey guys, okay, so we're going to start with derivatives of logarithmic functions. So first I want to talk about some rules to find the derivative of logarithmic functions. So first of all, if you have, there's kind of like three rules, but they're all really the same rule. But if you start off with something like this, so y equals log bx, the derivative of that is simply 1 over x log be, okay? Now, more often than not, what we're actually finding the derivative of is log base e. So if you plug that in, log base e, which is a natural log, let's just do it. So the second rule, so y equals the natural log of x. To find the derivative of the natural log of x, it's just 1 over x. Same rule here, except the base is e, log e. Well, log e is 1. So the derivative of natural log is 1 over x, okay? If you have something other than x inside, y equals the natural log of f of x. So let's say we have a function inside there. You guys see that? There we go. Then to find the derivative of that, what we do is we simply find the derivative of the inside over the original. And we actually did that here, you just didn't really realize it because the derivative of the inside is 1, so the derivative of x is 1 over x, okay? So that is the three rules to find the derivative of logarithmic functions. So let's do some examples here. So the derivative is simply the derivative here over the original. And then I do some simplifying, so there we go. Super simple. So that's a really basic one. So we also have to remember all of our rules that we've learned before, like those rules don't go away. So this is just a product rule. We have two functions multiplied together, so use the product rule. So I do the derivative of the first multiplied by the second plus the derivative of the second. Well, the second happens to be a natural log, so the derivative of the second is this. So this is the derivative of this multiplied by the original. And then we would have to do some simplifying. So this is 2x natural log of 5x plus x. Okay, so that was what would give you the derivative. And then here we have a trig involved, but we shouldn't panic. So we just do it the same way. So we do the derivative, this is a natural log, happens to have a trig inside. So the derivative of cos is negative sine, over the original is cos, and minus sine over x is the same thing as negative tan x. Okay? This one here, this is kind of a notation thing. This little 4 right here is actually the same thing as saying this. All to the power of 4. Okay? And then this is just a chain rule question. So chain rule is I multiply the coefficient by the exponent. I keep the bracket the same. I reduce the exponent by 1, and then I multiply by the derivative of the bracket. Well, the bracket happens to be natural log, so how I find the derivative of a natural log is I do the derivative of this over the original. Okay, so that's the derivative of that one using chain rule. Okay, so last example here, and it's the only one that we've done that hasn't been a natural log. It's been log base 7. And it's important to remember these. I find we don't do them often and people forget them, and it's like the one question they get wrong on the test. So we are going to have to go back to this rule right here. So when I'm finding the derivative of a log, anything other than base e, I do my life as normal. So I do the derivative over the original, but then simply I need to multiply by log of whatever the base I'm dealing with, e. Okay, so don't forget about that guy. That's how you do it when it is not base e. So that's the derivative of logs.